Hello and welcome. I'm Mustafa, a backend developer at VNGRS, and today I'm going to talk about Go. I've been learning Go for fun like a month, and I really like some of the ideas of the language, and I want to show you a quick demo just to give you the essence. So what I'm planning to do is I'm going over the tour of Go, which is a famous website for beginners and new learners. And first I'll start with the language syntax. I don't want to spend too much time on the syntax, and I'll go with other features like Go channels or Go routines, and stuff like that. So let's start. First of all, when you go to a Tour of Go website, web page, you see a web page like this, and there's a short tutorial on the left side, and there's a Go source code on the right side. Start with making syntax highlighting on. So the first few pages tells how to read the tutorial. So I'll just skip them. By the way, the tutorial is translated many languages, including Turkish. If you want, you can see it. And it's available for offline. So on the tutorial, there is a playground. It's working on your browser. There's a Go code, and when you click the run, it's executed by the server and results placed here. So if I change the string and rerun it, I'll see my change. And let's start with the packages. Go has a very simple package structure. It's just a directory, and you import it. For example, there is a package called FMT, which is printing and formatting stuff, and there is a library called math, which contains rand for for all the random stuff. For example, it has an int n function, which means generate a random integer up to n. In our case, it's 10. And FMT has println function, which basically println is all the same in all languages. And when you import a package, it's just prefixed with the package name, which I think is handy. And the exports are just convention. For example, some languages like Java provide keywords, public or private, just to scope functions. Go does not follow that route. It just follows the convention that if a function starts with a capital letter, it is automatically exported. So, for example, our function main is not exported, but FMT package has println function which starts with capital P, and it's exported. By the way, it's similar to the Python, so that's why most of Python folks love Go also. And functions are very simple, just func keyword, name of the function, parameters, type always follow the name, and that's it. It's a simple add function that takes two parameters, x and y, that are ints, and the result type is int. It's very straightforward. But it has some shortcuts, like if all the arguments are same in type, you can omit the type and just put it to the last one. And it also supports multiple results. You can return multiple values from a function. For example, this is a swap function that takes two strings and return them swapped. If I
have a question. Is it similar things to a tuple?
Yeah, it is actually a tuple.
Can we name the x and y with the return phase? For example, can I declare a x and y return tuple?
I didn't get the question.
Okay. Actually, I want to, for example, in main function, you call swap hello world, right? Can I put a label before the hello and world? For example, x and y colon hello.
Are you mentioning named parameters like this one?
Yes, label.
Well, as far as I know, no.
Okay.
But I'm not sure.
Why don't you just give this right now?
Okay.
I ask this because sometimes we need to more convenience when we are calling this kind of methods.
You can do it with functions, but you can do it with structs, a data structure that we'll see later. Okay, next one. And also there is a handy feature. You can name your return parameters. For example, this split function returns to a tuple, two elements, and they are named like xy. This is like Go automatically declare that variables for you, and you can use it to assign values, and then you just write an empty return, which will return the named parameters. You cannot use it when calling it, but you can use it when returning it. And variables, it's simple. Just put a var keyword and list all variables and the return type. But you don't usually use that syntax. It has a shorthand that we'll see before, but I'm pretty sure we'll see after. And if I run it, those are declared variables, but not a value assigned them. So Go just simply put default values for the type. For example, it's false for the booleans, and it's 0 for the int, and it's empty string for a string. Like that. And this is the syntax to assign initial value to the variables. In this case, the correct values are returned. And this is the short assignment syntax. Look at the K. You don't need to say var, or you don't need to say the type. Just assign, and you can use it. Most of the time you use that syntax. And basic types. Go has all the basic types you can think of: booleans, strings, integers, 8-bit integers, and unsigned integers, and byte and char-like type for Unicode points, floats, and complex numbers. And as I mentioned, Go has 0 values for different types. It's usually 0, all, false, all, empty string. And type conversions. You can convert similar types to each other. For example, if you declare two integers x and y, you can convert it to float, like that. I'm skipping. And yeah, as I mentioned, Go has type inference on shorthand assignment syntax. For example, where is type int now, but I change it to hello get type string, and it's automatically assigned.
Go is a type-safe language?
It is.
For example,
I'm repeating my question. Go is a type-safe language because, for example, when you set a default value, let's say 1, after that, can I change it as a string value?
No, for example, this v is a string now, and I cannot assign an integer
Okay.
after it's declared. Actually, it's
Okay, great.
like
Thank
this.
you.
It gives an error. And it has constants like this. I'm skipping. And it has numeric constants. There is no enum support, so people use numeric constants. And you can assign default values like 1 shifted 100 times. And this is the first part. So like the first part, I am going to go fastly on that second part, which is the syntax. And I want to go methods, interface, and concurrency parts. So let's go. Go has a for loop. It's plain old for loop. You just declare the variable, set the condition, and set the increment step. You can also skip variable declaration and increment step and use it normal loop like while. Okay, Go has no while loop. It just has for, and it's when you skip all the initials and increment part, it just plain old while. And actually, you can skip all the parts. It just give you infinite loop. And if statement, it's like your plain old if statement. You just omit the parentheses. It also has else part, like this. And speaking of this, Go actually has quite good tool chain around it. For example, there is a format button which is powered by Go FMT. It just formats the language. Because of that tool, it's like everyone likes same Go code. It's a very good tool for that. No style comments on PRs, if you know what I mean. And Go has a little shorthand here. You can actually assign a variable in the if declaration and then use it in the whole if block. It's a little handy syntax. And it has else clauses, as you guessed. So this is the first exercise. Maybe you know the Newton method to calculate square root. It makes us to implement one. So any idea how we can do it? Well, actually, all the code parts are here, so I just copy pasted. So you start with initial value, which is usually 1, and then you create a loop, and you simply improve your guess on the way, and you continue to do it while z is very close to what you need. So z is our square root. So if I take the square of z, it should be x minus epsilon. And if I declare epsilon like a small number, it should work. Hopefully. Yes. Not quite good.
Almost.
Maybe. No. Anyway. I won't spend time on live coding. Yeah. This is homework for you. So, another structure, switch statement. It's like switch statement in the other languages. For example, we are switching on runtime OS. If it's Darwin, we say O6. If it's Linux, we say Linux. Looks like. Yeah. Looks like we are running on table salt. And the major difference in switch statement, it can evaluate some expressions like this. So, for example, weekday. Okay, so we are getting weekday for today. And if the Saturday is today plus 0, which is actual today, we print today. If it's today plus 1, which means tomorrow, we print tomorrow, and so on and so forth. Looks like Saturday is too far away. Yeah, the
Now, why does it always take that date? It says on Go playground, it always starts at.
yeah,
That's why it says.
yeah, it's a playground environment, so the date is always this. That's why.
Can you
It's
change
different.
the time dot Saturday to time dot Wednesday in switch? Yeah.
Okay. Which is also not true. What's the?
You only need to change the when Saturday println there.
Sorry.
Can you change the println when Saturday to
It's
Wednesday?
actually Wednesday.
Yeah, it's actually. Huh.
It's acting according.
If the Wednesday is tomorrow, so looks like that date is Tuesday.
Hopefully.
Can someone try and see it? Okay. So also switch statement has a default, which is same as the other languages. And another interesting thing, you know, on lots of languages you open some resources like files or anything like that, sockets, some database connections or something like that, and you need to close them when you're done with them. So Go has a little helper here called defer. It takes a expression and evaluates it when the function exists. For example, if I run that, it should print hello world.
I have a question. So,
Yeah.
Would the defer statements be executed in order? So, can I have multiple defer statements in one function?
Yeah, you can. I'm not sure the ordering, but So ordering is reverse order. Yeah. Probably. Actually, it's the answer to your question. So they are last in first out order. Yes. Okay. Let's go with other interesting topics. Pointers. Everyone's nightmare. Well, Go has pointers, but don't has pointer arithmetic, so they are not that problematic. It's mostly call by value, call by name syntax. And structs. Structs are basic data structure in Go. You can define fields and its type. So as I mentioned, this field is capital X, so it's exposed to the outside of the module. And the struct creation syntax is like that. You write struct's name and its parameters. You can also use labels here, like this. Waiting for the server, and yeah. Also, you can use dot syntax to access and modify extracts variables, fields, like this. And you can create pointer to a struct, but here v is actually struct value and p is pointer, but we still can use dot syntax here, unlike C. And stack details. As I said, Go has default values for types. For example, we have vertex which has 2 integer fields, and I can either define all the fields or define one and omit the other one, or omit all of them. And it works as expected. Omitted fields got 0 or initial values. And arrays, Go has arrays, and unlike other languages, the array type has length. So for example, A is 2-sized array. I can assign hello and word to the fields. Or I can create an array called primes, which is 6-sized, and put 6 primes in it. And slices. Go has a thing called slices. It's basically arrays under the hood, but they have more performant operations. So you can slice the slices in constant time. And slice syntax is similar to Python. Those are references to arrays. I'm skipping. As you create arrays, you can create slices with omitting the length. And slices get default values. For example, it's an int slice. It's all 0 field slice. And yeah, slice has length and capacity. So unlike arrays, slice can extend. So they has capacity, and they have also lengths, which means how much of the slice is it's occupied. So for example, I can create a slice with 10 capacity, but if I don't put any elements in it, it's 0 length. And as I put the elements, its length will grow until it reaches capacity. and you can define a slice without assigning anything. It just acts like empty slice. Or Go has a make function, which is a special function to create slices or channels. For example, this one create a slice with 5 capacity. This one is 5 capacity with 0 length, which is empty slice that can hold up to 5 elements. And there's a built-in function called append to the slices. For example, if I create a slice S and append 0, 1, 2, 3, 4, just all appends it. And as you see, their capacity and length grows as I append them. And range, Go has a shorthand for iterating slices. It's a range keyword. When I have a slice like this, I can iterate it with index and value with the range functional keyword. So if I run this, I'll see that the index is put to the power of 2 and the value put to the other side of the equal. So it prints something like this. If I omit the value, I just iterate over the index. Or if I want to omit index, I just use underscore. Okay. So this is an exercise. If we define a function called picture, and if it returns a slice of slices, it just prints. So just let create one. Actually, I want to use indexes to make something colorful. Okay. Well, I should have, you know. Oh. Anyway, no. I don't remember the implementation. I should have, implemented before here. So I just skip it. Actually, it says almost half an hour, so I'll go faster. Okay, Go also has maps. M is a map from string to vertex. For example, it's like coordination of bell labs. And if I remove this, it prints all the map. And it supports map literals as a shorthand syntax. And it's even shorter, you can omit the struct name. And the map mutation works as you expected. You can assign new values or get a value or just check if it's there, or you can remove it. Another exercise. Let's just skip it. Okay. Go also has functions as first-class citizens. For example, here is compute function takes a function from two floats to a float, and if we call it with hypotenuse function, it just computes hypotenuse, or it just computes power. Here the results change as we pass another function. And it supports closures. You may have heard of them if you're a JavaScript programmer. So, for example, we have a function called adder, and it defines a variable, and it returns another function, and that function have access to that variable. This is basically closure functions with data. Next. Yeah. I'll skip that exercise, but you can create a Fibonacci with closure. And yeah. No. Okay, let's continue with Go concurrency features. So the tour of Go starts with Go routines. Go routine is a lightweight thread that's managed by Go runtime. So for example, we have a save function, just takes the strings and sleeps 100 milliseconds and prints it 5 times. If we call that function with Go keyword, it just creates a logical thread and executes it from there. As you can see, those two say functions executing concurrently. And Go also has channels. Channels like they are like Java's buffered queues, buffered concurrent queues, and they are for communicating between Go routines. For example, we have a sum function that takes a channel and a slice. It just executes the sum of the slice, and instead of returning, it just puts value to the channel. That's how separate Go routines communicate. For example, here we have a slice, and imagine it's a very big one. So we just create a channel and start two separate Go routines. The first one is computes the first part of the slice, and the second one computes the second part of the slice. And we wait for two values to return in the channel, and then we just sum them. It's a very easy divide and conquer algorithm that executed concurrently with the help of Go.
Will this start a new thread?
Yeah,
Okay.
they actually start two new threads.
Okay.
Actually, logical threads.
Logical
So
threads,
they are managed by Go runtime, like green threads. Some other languages.
So if I like fire up 5 Go routines, that doesn't necessarily mean that I actually
No.
create 5 threads. Okay.
No. You can actually start lots of Go routines, like millions of them. And for this example, we just create a channel, and channels by default not buffered, so they block on write and read. So we start two Go routines. The first Go routine will be blocked by on that line, and the second also. But on the main function, we try to read from the channel, and actually the thread that executes main function will block on that line. So that's how different coroutines communicate with each other. But if we don't want that blocking behavior, and we may not if we are coding a server, we can create a channel with buffer. So here we say it's a two-sized channel, so it will just buffer two elements, and we can, because of that, we can write two elements to the channel, and this will work. But if I remove the buffer capability and run the code, it will just deadlock, because this write will be blocked and this read will be blocked, and it's a simple deadlock. But if I put it back, it works as expected. And channels usually used with range clauses. So range just waits values to return to the channel. And for example, this main function, we just create a channel with 10 buffer, and we create a Fibonacci coroutine. So it will just calculate the Fibonacci's up to 10th Fibonacci, and on that for loop, we just range over the channel and print results. This for loop will exit if the channel is closed, which done here. If I remove that line, it will just hang and be a deadlock. So when you're writing a server, you just don't close the channels, and there are infinite for loops that loop over that channel. And you may, yeah.
Do you think it would be good practice to actually, when you create a channel, you automatically defer the closing of that channel so that
Actually not.
Terminate it?
Go guarantees that channel don't need to be closed. So you don't. Actually, closing channel is only, you must only close a channel when you want to signal that to the listeners that there will no more values. So listeners will do the cleaning and die simply. But if there will be values, like it's like a long-running process or a server or something like that, you shouldn't close channels. And this is the fun part. You may want to listen different channels because you may want to organize different things. So Go has a select statement for this. It's like switch statement, but works over channels. In this example, we listen X channel and quit channel, and when a value available is one of them, the block will be executed. For example, if we write a value to X, this block will be executed. Or if we write a value to the quit, this will execute it. If you are familiar with actors from Erlang or Scala, it's like an actors receive method. And this is where event-driven structure begins. You'll simply listen different channels and do something according to the event that happened. And like switch statement, select as default case too. If you need something to be non-blocked, I mean the previous example, you wait either one of the channels, but sometimes you may want to do another thing when there is no value available either of the channels. So this is where default case comes handy. For example, in this scenario, the tick will tick in each 200 milliseconds, and bomb will tick after 500 milliseconds. But no, before one of them ticks, there will be a default case which executed. So if I run this, it's a simple tick tack bomb animation. I skipped the exercise. So you can, well, you can use channels for multiple purposes. For example, Python language has generators, and you can use channels for generators. In this example, you get a tree and traverse it with using a channel on depth first or breadth first order. And sometimes a channel is not enough. For example, you are implementing a counter and map is not a thread safe structure, but you need to different algorithms to modify the map. So in that case, you need plain old mutex. The Go's default standard library provides them one of them in the sync package. So it's just a basic implementation of safe counter. In the main function, we create lots of algorithms to increment a k, and since it's protected with mutex, we wait correct result like this. And this is a exercise web crawler. Again, I want to do it, but that's all I want to talk about. Thanks for listening.
Okay,
Any questions?
why do you like to choose?
Why did you pick that Go language to learn just for fun?
Well,
Not the other languages.
well, I'm a Scala developer, and Scala is a complex language. So I just want to see the other approach, a simple language with simple structures. And I wanted to see how powerful it is. And looks like it's a quite good language, despite the fact of it's a very limited and small language. Another question?
Do you think? Do you think Go actually deserves to call itself a systems programming language?
Yeah, it is. Actually, it is a very low-level language. It's just a little bit lower than Java. So it's well suited for systems programming.
Yeah, but still, like garbage collection in a systems programming language does sound kind of weird, doesn't it? Not just sounds. I mean, there are like, for example, I mean, at least I think that when you use a systems programming language, there shouldn't be any randomness unless you want to introduce some. So, garbage collection by default is actually a random process, which is like scheduled by like completely out of your control, the developer's control. So I think that is kind of that might I feel like that might be a problem in certain cases.
Not really, because if you don't need a system critical component like real-time trading systems, you can, garbage collection makes programming very easy. So you can afford a garbage collection if the time precision is not that important for you. Most of the web services, most of the CRUD APIs, most of the command line tools can afford it. So it's not such a big deal.
What about testing?
I have an experience with Golang.
Mhm.
Also, when I was in the different places I write with Golang with Agouti. Actually, I saw the developers write the TDD with Golang, and they say that it is very easy and give some advantage to them. What do you know about it?
Well, Go's approach to testing is very different, actually. For example, this one is famous tool for Go. It's like Jekyll for Go. And Go's convention around testing is you write the code and you write test in the same directory. So, it's always there and you can see it. And it has a very simple but limited testing suite in the standard library. So you don't need anything extra. So it's super easy to start testing.
There was also a language with where you write the tests inside the source code, right? There was
Yeah,
something like that.
there are some. It's very low cost entry, so it just encourages programmer to do. Any other questions? Okay, thanks for listening.